Hi, my name is Maria Natalia, and I will present my work entitled The Effect of Ritalin During Adolescence Can Program Metabolic Parameters in Adult Life of Rats. I am a PhD student, and I was advised by Professor Paulo César Matias and Professor Kézia Palmarini. This work was based in Doherty concept that says that insults made in critical phases of the development may program the organism of health or disease in adult life. And the puberty is considered an important programming window. There is a gradual increase in the use of stimulants by children and adolescents, and the majority of them without diagnosis or with misdiagnosis of attention deficit hyperactivity disorder, the ADHD. And the Ritalin is widely used at this stage of the development, but little is known about its long-term effect. So the ADHD is attention deficit hyperactivity disorder and affects about 12% of the adolescents and may have multiple origins like genetics or environment or origins by changes in neurochemicals or neuroanatomical. So the action mechanism of the Ritalin is in the synaptic cleft and it is a psychostimulant that stops the recapturing of the neurotransmitters dopamine and noradrenaline and make them increase in the synaptic cleft and may have many changes in the central nervous system, like focus and executive function, or cognitive function, or memory, or in the motivation or performance. And the Ritalin may cause many changes in the organism during its use. Like lost body weight or reduction of plasma leptin or tachycardia, but after the treatment stops, the patient may have a rebound effect of increase of body weight. So thinking about all of this that I just said, our hypothesis was that the treatment with Ritalin in adolescents program for metabolic dysfunction in adult life. And our methodology was that we had two groups of animals, the saline and the Ritalin group. And when the animals had 30 days of life, we started to give the saline or Ritalin by gavage. The group saline received saline and the group Ritalin received Ritalin in a concentration of 5 milligram per kilo per day. So at 60 days of life, the treatment stopped and the animals were kept in the biotherium until they complete 120 days of life. And we started to analyze the parameters of body weight, food intake, water intake, fat and organs, weight, and the intraperitoneal insulin test and the oral glucose tolerance test. All the statistical tests were made in the GrandPad PRISM program, we made the student test and the value of P being statistically significant when P were under 0.05. So we will talk about the results now. So in all the slides on the left, you can see the results of 60 days of life. So just after the treatment with Ritalin. And on the right of the slides, you can see the results of the animals with 120 days of life. And in white, I am showing the saline group, and in black, the Ritalin group. The black squares were Ritalin, and the white circles are saline group. So about body weight, any groups in any day of, in any phase of life, they didn't have any difference between the two groups about body weight. The animals also didn't have any statistical difference between the two groups about the food intake. So the control group and the Ritalin group had practically the same food intake. Also in water intake, all the animals had practically the same intake of water during the treatment and even after the treatment. So in here, I brought the results about the oral glucose tolerance test. And on the left of the slide, you can see the results on 60 days of life just after the treatment with Ritalin. And we can see that we didn't had any statistical difference between the two groups about the decrease of glucose during the test. And on the right of the slide, we can see the results of the same test on 120 days of life. And we had only punctual statistic difference between the groups, and it might say that these animals had a little resistance to the metabolic reduction of the glucose. In this slide, I am showing the intraperitoneal intolerance, intraperitoneal insulin tolerance test. And on the left of the slide, we can see the results of this test at 60 days of life, just after the treatment with Ritalin. And this graph shows the decrease of glucose during the test. And this graph shows mathematic calculation of KITT. And it shows the insulin, the possible insulin metabolic in the animal, the organism of the animals. So it shows that the Ritalin group is more sensible to the insulin than the saline group, the control group. And also here on the right of the slide, we can see that the 120 days of life 60 days after the treatment with Ritalin, the Ritalin animals also shows an increase of the sensibility of insulin in this test. In here, I am showing the fat weights of these animals. Also comparing the 60 days of life and 120 days of life. I brought the retroperitoneal, periepididymal, and mesenteric fat. And we can see that the Ritalin animals had a reduction of the periepididymal and the mesenteric fat, contradicting the 120 days of life that the Ritalin animals had an increase of mesenteric fat comparing to the control group. So our conclusion of this work is that the use of Ritalin in adolescents induces an increase in insulin sensitivity and leading to a metabolic dysfunction. I want to thank you very much for your attention, and I am sorry by my English and my mistakes. And I want to thank my advisors and my colleagues on the lab. Thank you very much.